Assalamu alaikum, my dear students. How are you? Hope you'll be fine and okay. I welcome you all back into the online classes. Uh, Today we will start from unit number 7, the properties of matter. Unit number 7 consists of uh, the about the properties of matter. So let us start with the name of Allah Almighty. Bismillah ar-Rahman ar-Rahim. The first topic, the first point, the first topic is matter. That what is matter? The first topic of the chapter is matter. Now, class, you know that matter is in fact anything or any object. This is what your class 6th or 5th grade topic. Anything which has mass and occupy occupies space, that is called matter. Is called matter, right? So matter, that is from the speck of dust to the bodies as big as the astronomical or the heavenly bodies, they are all matter. The speck of dust found on your boot is a matter, but the sun, the earth, the moon, they are also matter. Why? Because they have what? They have mass, and they have what? And they occupy space. So this is why they are termed as matter. The you yourself matter. The chair you are sitting on is matter. The tablet or the smartphone right now in your hand through which you are watching my lecture is a matter. The pen in your hand is matter. The notebook is matter. Everything is matter, right? For example, even the air, which is transparent and which we cannot see but we can only feel its effect, that is also matter. Why? Because they occupy space and they it has a mass. For example, look at the balloon. When you inflate the balloon, then what happens? You see that it occupies space because you are putting air inside. Or look at the gas cylinder. When it is empty and when it is filled, then what do you feel when you try to pack? Definitely the one which filled with gas is more heavier the one which is empty. So that is all matter. Even the living organism, the microbes, the bacteria, the virus, they are all matter. So in short, what I will say, that matter is in fact what it is, the stuff from from which the universe is made. From which the universe is what? The universe is made. So that is, the universe is not alone made with the matter, but it might be one of the component of what? One of the component of the universe. Because actually our universe consists of what? If I write here the universe, so universe is consist of matter, uh, energy, and I explain in great detail to you about the energy, matter, energy, and space. You also know the space where the density of the matter is very low, and time, and you I explain about time to you during my classroom lecture also, that time is actually the duration elapsed between two events. So these four things together, the matter, energy, and space-time, they form universe. So matter is in fact one of the most important component of what? The most important component of the universe. Now, in this physics, in this chapter, we will confine ourselves only to the physical properties of the matter, right? And the effect, most probably physics deal with the effect of stress and temperature on matter, that when that is when the temperature of the matter changes, then what kind of changes occur, that is what we are interested in. And similarly, when the matter is under stress or pressure, then how it behaves. This is what we will be studying in our this unit. So you just see a class, if I just start to discuss the broad classification of matter with you. So let me tell you that this matter, about the classification of the matter. Uh, what is the main classification of the matter? Matter is mainly classified into um, three main uh, categories, or three broad categories. Matter, it is the physical classification. What? The classification of the matter. So better to write the classification. That would be even more good. So you see the classification of the matter. Broad classification, okay? Classification of matter. So we can classify matter into three broad classification, right? The first is the physical classification of the matter. The physical classification of the matter. And the second classification, and the second type is the chemical classification of the matter, that how matter is chemically classified. And third important one is the electrical classification of the matter, right? That is the first classification of the matter, is that the physical classification. So what is there in the physical classification? In the physical classification of the matter, you know that it is classified into solids, right? Later on we will discuss about solids also, that what are solids. And then the next classification is the solid, liquid, and then you have the gases also, right? And the fourth one is the plasma state of the matter also. The plasma, sometimes we are also called the ionic state of the matter. So this is the physical classification. For example, look, solid. So even as a matter, for example, you see water. Look at water. Water in the ice form is a solid. In the water by itself is in a liquid form. In a steam form, it is gas, right? And when it you heat to a very higher temperature, then it will shift towards the fourth state of the matter, called the plasma. So you have the first state, and you have the second state, and you have the third, and you have the fourth. So actually whatever you are learning here in your this unit, and they are telling to you about the uh, state of the matter, so in fact they means the physical state of the matter. In the chemical state, for example, the chemistry teacher might tell you best than me. So for example, you might have the mixture, like that one, the mixture, and the you have the then the compound, right? And then you have another homogeneous mixture, and you have the non-homogeneous mixture, the chemistry teacher might told you, and the heterogeneous mixture. And in the compound, they might told you that the organic compound and the inorganic compound, like that you might have learned, and the stories goes on. And I don't want to take much interest in this because I know very little about the chemistry. So the organic and the inorganic, that is not our appropriate topic here. And of course, the electrical classification, which is of our broad interest. And the teacher might told you about the metals, right? And the non-metals, or like that. And a third category, the metallites, like the metallites, like that are simply, sometimes we can say that conductors are insulators. There are exceptions also, are insulators and semiconductors. And what? Semiconductors. For example, graphite is the only non-metal which behave like a metal. So exception is always there. And inshallah, we will discuss these at their appropriate places, right? So these are all the broad classification of what? The broad classification of the matter. Now, whatsoever is the situation, whether if it is solid, whether if it is liquid, and whether if it is gases, or whether it is plasma, or even when it is superatomic state also, whether it is homogeneous mixture, non-homogeneous mixtures, organic compound, inorganic compound, whether they are metals, whether they are non-metals, or whether they are insulators or the conductors, they all have one thing in common. And plus, do you know what is common between them? And definitely, they all are made up of molecules. Now, you know what are the molecules? In fact, molecules molecules are what? Molecules are just like you can say that they are the what? Molecules are what? Molecules are just like the group of what? The group of atoms. The group of what? The group of atoms are called the molecules. These group of atoms may be similar or might not be similar. For example, look in the case of the hydrogen gas. So this is one molecule, and hydrogen. So the same molecule, but it is not necessary all the time. For example, if you see the molecule of water, H2O, so here you see that the atoms are different, right? Two hydrogen atoms and one oxygen atom, and they combine to form what? The molecule. So molecule is in fact what? The group of atoms which may or may not be similar. So it means that molecule is not here the only smallest part of the matter, and in fact it goes down and we come to the atom. Now, what is the atom? Atom is in fact the in long before it was defined as, because even it is a Greek word which means indivisible, but these days the atom is considered to be a divisible part. So atom is the what? And the smallest part of the matter. What? The smallest part of the matter, which which consists of a nucleus with orbiting electron or electrons. Why I use electron or electrons? For example, electron when it is hydrogen atom. there is only one electron, and electrons, when it is other than like helium or like oxygen, then they have the electron. So even atom is further divisible, and if you see, so atom is actually, in fact, this is the consist of what? It consists of the nucleus part. And now, as I told you, that it consists of what? The nucleus even consists of the, as I told, that it consists of what? That it consists of the atom consists of the nucleus with orbiting electron, and the electron moves around the nucleus in a fixed orbit, right? So that is the lowest part of the matter down. As you see, nucleus is in fact what? This nucleus, it is the central, highly dense. Later on I will be explaining to you density. Highly dense, and the positive charge part of the matter, and the positive charge part of what? The positive charge part of the matter. So this is the point where we want to go there, right? So that is how the basic this is how it, the basic of the grassroots the matter is. So you have seen all these, right? Now let us see that matter, and I told you about the uh, types of the matter also, right? But not in that great detail. Here by the types we actually means what? The physical only, the physical types of the matter. Okay, physical types of the matter. But before this, I just want to tell you about the kinetic molecular model of the kinetic molecular model of the matter. That is the 7.1. Kinetic molecular kinetic molecular model of the matter. This can be best explained on the basis of the kinetic molecular theory. Okay, the kinetic molecular model of the matter has some important features, or this is what I call the kinetic molecular model, kinetic molecular theory. First of all, we'll tell you or define you that what is it. The kinetic molecular model or theory, it deals with the way, it deals with the way in which the arrangements in which the arrangements of the particles the particles may be what I'll be telling to you later on, in which the arrangements of the particle describes the properties that substance will possess, that substance will possess, particularly the state in which it is likely to be found, in which it is likely to be found, right? So let's see what I mean actually by the particle. Atoms are molecules. Atoms are molecules. That's what I mean to say about this. Okay, and the properties, and second, the state in which it is like to be found in the kinetic molecular modular theory. The kinetic modular theory, it actually deals the way in which the arrangements of the particles describe the properties that substance will possess. For example, let us see how. One simple example is I told you that look at the solid, sorry, look at the liquid, the solid state. For example, look at the ice. Ice is one of the state of the water, right, in which it is in a solid state and it has some shape, right? But look, when it is in the liquid state, the water, it does not have the shape of its own. So you have seen that water in a two different states may have different properties. Similarly, look at in the gaseous state to the water. So why they have these different properties? It is because of the arrangements of the particle, right? So that is one of the most important point here, that how they describes the property of the substance. Water has a different arrangements of molecule when it is in its solid state, when it is in a liquid state, and when it is in a steam, that is a gaseous state. So the salient features of this kinetic molecular model are the salient features of this KMT. Salient features of the KMT, sorry, they are first. The first one is that the matter is made up of particles called molecules. Matter is made up of what? Matter is made up of the molecules. And now I don't want to discuss this because I already told you that molecule are in fact what? That molecule consists of group of atoms which may or may not be similar. So at the grassroot, may all the matters are made up of what? Molecules, whether it is in the solid state, in the liquid state, or in the gaseous state. The molecules are always continuous in motion. Molecules have what? These molecules have continuous motion. These molecules have what? These molecules have the continuous motion. Now, the continuous motion of the molecule, this motion may be free, this motion may be bound. Like for example, it might be a random motion, it might be a vibratory motion, right? So they have what? They have the they are in the continuous motion. Depends on the type, the physical type of the matter. For example, if it is solid, then the motion may be vibratory. If it is liquid, then it could be along a zigzag path, or if it is the gas, then the motion of the molecule will be totally free. The second important point is molecules. There is what? Between the molecules, there is what? There is attractive force. There is what? There is attractive force between what? The attractive force between the molecules. And it is this force which gives it shapes, right? And this is the molecular force which keep them bound together, right? So this attractive force, that is it can be varied, right, that it increases or decreases by changing the properties of the matter. For example, look, the temperature effect. So if you increase the temperature of the matter, then the attractive forces between the molecules of that substance will decrease or will weaken, right? So temperature has an effect on this attractive forces. This kinetic molecular model is capable to explain all the states of the matter, right? So all the molecules, since they are in motion, so molecules, they have energy. They have what? These molecules have energy, and we call it the internal energy. The internal energy of the molecule. This energy may be kinetic, potential, kinetic because of the motion, and potential because of the intermolecular forces. Right? Now, these are the features, and look, the conclusion of the KMT. The, the conclusion of the KMT is the conclusion of the KMT, kinetic molecular model. Look, as I told you that it can explain various physical state of the matter, but the broad conclusion in the light of what? In the light of the kinetic molecular model, yeah, KMT, kinetic molecular theory, we can what? We can design material, we can design material of specific properties are according to our own requirement. For example, look at the plastic. You see, it is not naturally available, but by studying the KMT, we design plastic, and you know it is available in various strength, various shape, even some are temperature resistance also. So this all happens because of studying what? The kinetic molecular theory. So the kinetic molecular theory help us to design new material of various strength and various strength and properties, right? So this is how the KMT help us. Now, on the basis of the kinetic molecular theory, we are capable to explain the types of what? To explain the types of the physical types of matter. The first one is the solid. So in solid, you see that and the solid, for example, like the pen in your hand, the stone, the mate, that is the metals, the pencils, etc. They have a fixed shapes and volume, right? As you see, for example, look, the pen in your hand has a shape, right? And it has a cylindrical shape and it has a volume. The molecules are very closely packed together. So you see here, the molecules are what? They are very closely packed together. The molecules are what? Closely, they are closely packed together. So the molecules are what? The molecules are closely packed together, right? And the attractive forces, the intermolecular forces are very strong here. Okay, so the motion of the molecule is what? The motion of the molecule is vibratory. They possess vibratory motion about their mean position. So the molecules are closer together, very closely packed together. They have strong attractive forces, right? And they have strong attractive forces, and the motion is what? Vibratory. The atoms or molecules do not move from its own position, but they vibrate about its mean position. So this is what happening in the when it is in the solid state. So in solid state, they have definite shape and volume. So the arrangements of the particle is in that way. Now in the liquid, the story is somewhat different. In the liquid, the distance between the molecules of the liquids are much more greater than what? Much more greater than the solid, as you see here. So they are little bit distance apart from each other. So this causes the intermolecular forces a bit weaker than the bit weaker than the solids. Molecules, that is the like in solids, the molecule also having a vibratory motion about their mean position, but they are not rigidly held with each other, and they molecule have what? They have motion like along a zigzag path like this. The molecule, their motion of the liquid molecule are like this. They can move randomly in any direction, and they change its direction because when they collide with each other, the attractive forces are weaker than that of the solids, right? So water is the best example, and then there are milk, water, and oil, etc. They are all liquid. Liquid has the ability to flow. What liquid can flow also, and they do that is liquid do not doesn't the liquid doesn't have its own shape, but when whatever container or vessels you put it get that shape, right? The next one is the gases such as air or air have no fixed shape or volume. Just see here, the molecules are free. They can fill any container or any space available to it and just take that shape. The molecules have random motion and move with a very high velocities. The intermolecular forces are very weak as compared to the gases and liquid. So gases are much lighter than solid and liquids. They can be squeezed into volume, means that they can be compressed to a greater strength, right? The molecules of the gas are constantly striking the wall of the container and thus can create pressure or exert pressure on the wall of the container in which it is kept. So that are what? That is the gases. Oxygen is a gas, hydrogen in a gas, like that. The next one is the plasma. Plasma is what? Plasma is the fourth state of what? It is the fourth state of the matter. Plasma is what? Plasma is the fourth state of what? It is the fourth state of matter. It is the plasma consists of highly ionized gases. Highly ionized gases. It consists of highly ionized gases, right? Or it is sometime we can say that the ionic state of what? It is the ionic state of matter. So when matter is in its ionic state, then it is changed into what? Into the fourth state of the matter, right? That is the called the fourth state of what? That is called the fourth state of the matter. I'm sorry for this disturbance. Okay. So plasma is what? That is when the gas is in its ionic states. The normally gases are bad conductor of electricity, but when it is in its ionic state, then it is good conductor of electricity. So this consists of the positive ions, and that is when the positive ions and the electrons get separated in the presence of the electric or the magnetic fields, then we can obtain plasma. Plasma also exists in neon and in fluorescence tube when they glow. Mm, right? Most of the matter that is found in the universe is actually in the plasma state. For example, in stars like sun, the gases exist in the ionic state. So plasma, as I told you, is highly conducting state of matter, and it allows the flow of electricity, right? So we can obtain plasma by two ways, okay? That how to obtain plasma by two ways, right? The first one is by heating the gas to a higher temperature, by heating gases to a very high temperature, right? And the second one by passing electricity through the gases, by passing electricity through by passing electricity through the gases, through the gases. Is it clear? So this is how we can obtain plasma by heating gases. For example, look, the hydrogen gas like in the sun. So this is how we can get the plasma. And look at the tube light that passing electricity through gases, we can obtain what? We can obtain the plasma. So this is all about our today lecture. So inshallah, about the density, I will tell you in my next lecture. So thank you very much till date, and see you in the next lecture. Allah Hafiz.